Okay, so I'm Dan. I'm here. I graduated from the University of Manchester in 2015, as Carla said. So I've been working at ARUP for the last 18 months. And when I did this project, I'd had about 8 months experience. And can I just say how great it is to hear all the conversations about how good all these presentations have been and the broad variety. Yeah, thanks for inviting me. So I want to share some lessons about what I learnt when I got the chance to have a bit of free rein and make some mistakes in a safe environment. And hopefully it doesn't matter whether you're a structural engineer, mechanical engineer. I think these lessons kind of breach all barriers of that. And whether you're a student on a project as well, hopefully it might shed a bit of insight. So it's nothing breakthrough, but hopefully it will just be a little bit interesting. So those bridges are we'll come back to those at the end, but I'll take you on a little bit of what I went through. And when I was reflecting on all these lessons that I think I'd learned, but I'll still be learning for the next 10 years, I sort of found that there were some themes, and that these themes perhaps continue right the way through your career, even 50th year maybe, I don't know. But the connections are really important, both structural connections and networks. That time is really an important factor in what we do, and about your expectation. So I'll touch on those. And throughout what I'll be talking about, it was mentioned previously about the stages through a project from zero to all the way done. These are the REBA stages of work that the Royal Institution of British Architects have established, and they help give guidance on what goes on at each stage of the project. So I'll be using that as a bit of a background and a reference. And it's not often you'll get to see 0 to 7 within 3 months. So that was a really, really good experience for me. So at the project, I was approached by a lecturer who I'd worked with quite closely at uni. And he said, well, actually structural engineering doesn't really have many exciting things. We have some little small scale models, but formerly a student and all the aerospace people are taking over because they've got all these fancy, like the flight simulator and the Formula car and stuff. So we want something for open days to sort of entice people in and show what structural engineering is about, and civil engineering. And it goes back to this principle that's been mentioned a few times already about safety. We need to design for a range of criteria. The ideal at the top is where everything's all hunky-dory and it doesn't fall over or anything. We want to really avoid anything breaking. And the last thing is actually a lot of the materials we design from flex a lot, and they'd be fine, but actually it'd be quite uncomfortable for you and me to be walking on a floor that does this. Structurally it's fine, but we've got to design for people. That's people use it. Why else would we build things? And the fact that this project, he wanted it to be built by students, so it needs to be built safely, and also a good use of materials. Demonstrate what we do is important. So the bridge itself, 3 meters span, quite small, but enough for a person to walk across, to be built within the constraints. So how do you start a project like this? Well, like any project, the appraisal of materials, some really quick ideas, just pencil and paper, and some thoughts about what might trouble you most, because that's what's going to trip you up later on in the project. So had a quick feel for form and materials, and now it was time to find someone to make it. And this was actually the first lesson. It's about using your networks, a bit like I and all the other networks that we're here for. Use those networks, they're really good. So I contacted over 25 fabricators, and only 4 of them replied. 2 of them because I knew them really well, and 2 of them because I spoke to them on the phone and tried to convince them that the project was worth doing. And at this stage I didn't expect. I spent a long time searching for people to do it, and only a very small amount of time actually doing what I needed to do. So from this, The second one is about broadening your horizons. Again, another theme that we've been talking about. Learning how to find new contacts efficiently is quite good, and these are one of the best ways, talking to people and learning what other people do. So, in the meantime, I met with our client, showed him these ideas, and he'd had a little think as well about what he wanted further from the project. And the meeting was great. We distilled a few ideas and reined in the world of possibility to some more simple ideas. And simple was the theme because we needed to get our message across. If you're trying to demonstrate a message to students or to people who don't even know what engineering is, you need to be able to show it in a clear way. And there was also some technical concerns about he wanted these bridges to be able to grow and evolve over time, which meant that the thing that was holding them, the supports, were really important to try and make flexible and adaptable. And at that point in time, we said, let's forget about the arch. Let's just try and do a simple beam. And he was quite interested in that. And you might think, well, what's a simple beam got to do with a lot of stuff? Well, actually, it can show you all about deflection. It can show you about failure, and it can show you about how if you use material in the right way, you can actually get a very efficient structure. So, we developed our design a bit more. You can see we've moved on to develop design now, stage 3. And there were lots of problems that you can try and sit in your bubble and work on a desk, but actually it doesn't really work because you don't often know what's going on when it's being built and when it's actually being fabricated. So getting a contractor in early is really important. So we had a meeting, and in that workshop, it was really, really good to solve all these problems that we just haven't even thought about. Sometimes we do sit in a bubble. And so what we should have done is really had a second one, because it came later that the problem lies in the detail. When you really focus in on one or two little aspects, and you're doing your design and your sizing elements or whatever, that's all well and good, but if you can't get the bolt in the right hole past another piece of metal, it's not going to work. So there's a limit to what drawings can do. Another lesson that I learned was that actually it's good to make assumptions, and that's in large part what we do as engineers, is make assumptions about how things work in the first place. But if you can actually create something from real data, it makes a big difference. So I quite like the quote from the Simpsons movie when Arnold Schwarzenegger was about to choose which option to fix the country or blow up the country or whatever it was. And he said, I was elected to lead, not to read. And he just chose one. But actually reading is really, really important. I learned a lot of lessons from Jacques Heyman, who taught me some things about arches. So just encourage you to read, whether it's as part of work or outside of work. It's really good. And so these were some of the inspirations that came from that reading. And particularly Polanyi, probably never heard of him, but in 1748 he developed the theory from a hanging chain that's in pure tension and inverted it being pure compression, that actually you could build an arch from pure spheres. Clearly friction would have to be accounted for, and there's other various different things that make this rather an ideal case, but I had a good read about that, and that was really interesting. So that's kind of what we're aspiring to as well. I'm quite ambitious in what I like to do. I try and fit too much in usually, so time management is sometimes an issue. But you can't, especially for open-ended problems, do absolutely everything. And sometimes it's easy to run away with what your ideas can give you. But sometimes you have to limit yourself and stop yourself and say, no, let's do the simple stuff and let's stop here. And that's a big lesson for me personally. One of the final lessons about the individual stages in the project was stepping out of what you're doing. Again, getting out of your bubble and looking at things from a different perspective. Maybe inviting someone in who's not been on the project and just saying, can you have a look at this? And if you do that, it can give you the invigoration and the drive to get better results later on. So step in, step out, and look at what you're really looking for, because this can help you. It can help you give success. So I've talked about each sort of different stage just before construction, which we were able to pass off onto a fabricator. But there are some lessons that kind of developed throughout the whole thing, that every time it was coming up again and again. So the first one was about forecasting time. So I was, I've said before, fortunate enough to be given the opportunity to sort of do this on my own steam. I was given as much support as I needed. So I thought, well, okay, let's plan all the activities out, see how long I think it will take me. And actually, when you guess, you probably don't know. And when you're a young engineer, you've got loads of learning to do. And so sometimes managers don't account for this. And you forget about it as well. And you end up staying late, or you end up reading loads on the train. And that's all good stuff. But yeah. So I came up with this equation. Glad it got a laugh. It didn't last time. So us as engineers often have to work with very complicated equations that we don't really know what they mean. So don't try and get bogged down in it. But basically, if you have a complex project and you've got a lot of learning to do and you're a young engineer, the chances are that it's going to take longer than you think. That's the long and short of that. I had less than a year's experience. It was a fairly complex project, quite small, which often means it's actually quite big. But I reckon that if I did this in 2 years, I reckon I'd do it in half the time. Because when you have learnt all that stuff, that's what moving forward is all about. So as part of this, I created a big program, trying to think I had it all under control, and you've already seen that I spent a lot longer than I thought. And so this kept developing and growing in size. But this is a really good way to manage how your budgets are being spent and planning the upcoming tasks. Very useful tool. So you think you're all on top of it. But as I've just said, often if you don't know what you're doing, your guess is probably going to be wrong. Especially if it's something you've never done before. Which is why we have experienced managers that have the real data. They have it stored up here. They might not have it all written down, but they know how long things take and all that sort of stuff. So how can you combat that as a young engineer? Well, try and set yourself false deadlines. I mean, I really struggled with this at uni. If anyone could give me any tips, I'd be interested. So it's about having that challenge to push you to do things, because if you set long deadlines, you'll probably use all of that time. But having that contingency as well to fix any mistakes, because the chances are you will make mistakes, and that's a really good thing. So don't let it run away with you. The last lesson that I want to share with you is about the promises you make. Particularly me, being someone who's really ambitious, has loads of crazy ideas. I like to think that I can do everything, as I've already said. And the first two lessons that I've just mentioned, so the time and the program, help to manage what your expectations are, real data. But you need to be really careful at early stages. And I'm sure you've seen this graph where at the beginning of a project, you know that you can influence the project and it can go in any direction. And as you go through that project and you develop your ideas and you hone in on one idea, the cost of changing that project into something different is rising exponentially. And so my graph of this is about how you start to think more and more and develop your expectations according to what reality can give you. And at some point, your expectations have to meet reality. Otherwise, it doesn't exist. And so on new projects, it probably will look like this, where they only really meet right at the end, because you kind of don't know what you're going to get. You've got it all down on paper, that's great in theory, but it doesn't actually happen in practice until it's happened. And some other projects might meet much earlier on, because you know exactly what you're dealing with. So drive carefully, especially at early stages. So those are the lessons. How did I get there? Well, started as a structural engineer designing for deflection versus stress. Now that's quite an odd thing to do, because we don't usually allow things to deflect. So that was a really interesting part of what we had to do. And also producing quick drawings to allow the fabricator to get an idea of what the cost was, doing some analysis to figure out whether my members were big enough and whether this bridge was actually going to work. Again, producing costing drawings, and then producing stuff eventually when we'd ironed out all the problems. I say all, but we didn't iron out all the problems until it actually been built. But producing construction drawings like this. And we did all these by hand just because we were kind of doing them on the train, and yeah, not enough resource in the project. And again, that's some of the learning that I had. So again, producing detailed drawings of what was going on with all these tiny intricate parts of this bridge. Or I say bridges, because there were lots of different types. Yeah, detailing to someone else. That's what I found is difficult, was I knew everything, what was going on in my head, but no one else did. And even when I thought I'd shown everything, one of my engineers came to me and said, how does that even work? I just hadn't written something down. And then I talked about the foundations as well, about how that can incorporate all these different structural types and try and be as flexible as possible, but at the same time be able to be carried around by a few people. And eventually it produced this. So this was the beam, and you can see me there measuring carefully what deflection for the exact, and actually the numbers work, physics works. It's good, that's what we do, that's engineering. So although I was surprised, you shouldn't be, it's what we do. And the arch was a really interesting one. So back to Pellini in 1748, he came up with these surfaces that weren't quite right. And so I took that and I said, well, what if you could make it move? What if you could see the failure as it's happening rather than it just go boom? And so that was what has happened. And I'd love to show you a video, but it doesn't really work very well. So I'll just show you that. You can see each member is slightly curved, and as it collapses, you can see it roll, and it's a bit dynamic. So that was a good bit of fun. And you can walk across, and this truss design was about construction and putting lots of little things together and working as a team. So that's me. That's what I did on that project. I'll talk about the structural engineers for maybe not quite as long as 10 minutes. But has anyone got any questions about that project or anything in it?
This was a real project. It wasn't just like a student exercise.
Yeah. So it was paid by the University of Manchester to deliver these bridges. Yeah. So good learning experience. Any more questions?
Are you using CAD now? Have you got the resources?
Yeah. Well, with 3D Revit and yeah. Yeah. Okay. So if there's no more, I'll move on to the institution. And unlike Valerio said, I'm not going to tell you everything about the institution, just a brief summary of what we do. And it's much like every other institution. We're about keeping our members happy and making sure that everything's all right. Just can I get a show of hands of who knows what a structural engineer is? Yeah? Good. Okay, I thought as much, because there's been a good mention of it before. But we deal with the analysis and the design of anything that needs to stand up, as you've seen, roller coasters or stadiums or any of that kind of thing. And we seek to minimise the internal stresses of materials so that structures can be built elegantly, safely and cost effectively. Now you may have an image of us looking through microscopes, but actually it's the whole form of the structure we care about, right from foundation to the top of the building. And we look to meet demand. We look to the vision of the client or the architect to allow them to do what they want in reality. So we combine creativity with physics to manage projects so that it's designed and built safely, and like the image in the screen, help create spaces that are usable for people. Again, why else would we build things?
I have one quick question.
Yeah.
When you have one of these projects, obviously architects are involved. But what stage does the architect start to involve himself with people like you? Is it the late stage or right away?
Sorry?
At the time to make trouble.
Yeah, probably too late maybe. No. So usually the first two stages, 0 and 1, are the client and the architect talking it through themselves. And then at that point, concept stage, they need to think about how it will stand up. And some architects have a really good idea, some don't, and think they can get away with no columns anywhere. So yeah, it varies, but usually quite early on, concept stage. Some specialisms like acoustics come in at that stage as well. It depends on the project. Project we're working on just the other side of the green square is arts and media building, so it's all about acoustic performance and noise, theatres and things like that. So that was quite a different aspect as well. So how did the institution start? Reinforced concrete was first used in the 1850s. Well, actually, it was used 2,000 years ago when they mixed a bit of lime and some hay and that sort of thing. But when iron bar was introduced into the matrix of concrete to strengthen the brittle material, it was about the 1850s. And by 1897, getting my words mixed up, by 1897, independent contractors had established their own secretive, patented methods of doing things. Notably the Hennebeek system and the Coignet system. And in the same year, Edwin Sachs, an esteemed British architect, established the British Fire Prevention Committee. And at the same time, the first concrete building in Britain was built. And the thing about fire that Edwin Sachs was involved, he was involved a lot with theatres, and at the time theatres were quite a problem for fire. That's why we have fire curtains. So he was really interested in concrete because concrete protects the material that does all the work in tension, and it's also really good and strong in itself in compression, and it's a robust material. But architects were subject to the monopoly of these systems and their heavily guarded secrets. So they wanted a representative body. And so Edwin Sachs was really keen to have some design guidance of this new material and independent influence on the building regulations of the time that had no provision whatsoever for reinforced concrete. So in 1908, the Concrete Institute was set up, driven by Edwin Sachs, with the ambition of becoming an industry expert and shaping the building regs of the time. In 1912, the scope was broadened to include more particularly steel, but also all other materials. And in 1922, it officially changed its name to the Institution of Structural Engineers. And in 1934, it received its Royal Charter. Today, it has over 27,000 members in over 100 countries all over the world. So what are we here for? What do we do? Well, like many of the institutions you've heard about today, we provide specialist guidance for our members and people who work in the industry. We're internationally recognised source of expertise, information, and all sorts of events concerning the profession. And at its heart, its purpose is to uphold the professional standards and ensure that its members are highly skilled. It does this by producing guides and documents that we use on a daily basis, setting the standard and precedents for what we do. And it also celebrates excellence because we can learn a lot from the good things. And this is one of the award winners incredibly thin shell structure. This is Valencia oceanographic, I think it's called. And by the way, does anyone know the difference between institute and institution? No? Okay. Well, hopefully I've not got this too wrong, but an institute is founded to promote the cause of a particular subject matter, the concrete institute, but an institution is to serve the matter in question as a whole, to study it, to facilitate and explore and expand its important role in society, but also to serve society, not just its members. And the purpose of the Concrete Institute still remains today, to provide specialist guidance for its industry and its members. That seems like a repeated slide. Yeah, there we go. And so part of the Celebrating Excellence and Success is the annual global conference, the Structural Awards. This promotes best practice and rewards technical excellence. And it does so because of the 50 regional groups throughout the world that contribute to the organisations and the personal development in local areas. What's more, individuals that have made a special contribution to the profession and advancement of our field are awarded with a gold medal. And I encourage you to find out who in this room has got one. So here in our local branch, all our members and the chairman and the board are all volunteers acting to organise and run events, much like what you've seen and heard with all the CPD sessions and the technical sessions, the field visits, all those sorts of things. Particularly in terms of our project technical calendar this year, it's really broad range of stuff you wouldn't expect maybe. So we learnt about the BIM Northern Hub, we learnt about lessons from failure. And in the next couple of months alone, it's got really broad topics of counter-terrorism and graphene and bridges prosperity and loads of others, and that continues throughout the whole year. So it's really interesting to be a part of it. And we also have our local awards. So we have the Northwest Structural Awards. And this is a chance for us to celebrate local projects that have maybe made a difference or they've been a bit different and shape the world around us to be a better place. And finally, I just want to say that you'll hear of the Young Members Committee, who quite a few are here today in organising it. But the region really benefits from a strong and diverse range of young membership, which serves the profession in a similar way to the main committee, organising social events, workshops, etc., etc., etc. So here's a really good presentation we had middle of last year, helping to develop our range of skills. We go and visit sites and see what it's really like, try and get out of our bubble a little bit. And of course, we try and have a bit of fun. So that's all from me. I hope you've enjoyed it. I hope you found it useful. If you got any questions, then please ask.